A stem and leaf plot is a graph of what we call discrete data, meaning that there's no decimal after it stops. And what it does is we can plot two different values, or in this case, homework scores, on the same plot, and we can look for different distributions. So what we're going to do is we're going to pick off the stem. The stem is like the stem in a leaf. The stem attaches first, or the leaf attaches to the stem. So the stem, if we look here, are going to be the tens place. So the lowest score we have is 45. So we're going to go ahead and list these out. They need to be in order and evenly spaced. We'll do homework scores for A on the right-hand side. So if we took A, I can see that we have a 45 and we have a 48. So the 4 is the stem, the 5 and the 8 are what we call the leaf. So after the 4, we order them. There's the 5 and there's the 8. So when we see those numbers there, I see 45 and 48. Then looking further, it looks like I have a 52, so I'll put a 2. I have no I have a 69, and I have, so we'll cross these out here. I have a 76 and a 79. So we'll put the 76 and the 79, and then we'll do the 80. So if there's an 80, you're going to have a 0 for the 80 and 86. We've already plotted the 69 and then the 92 and the 94. So I can look at the distribution. This person was spread all over in terms of their test scores. They weren't very consistent because they had some in the 40s and they had some in the 80s and 90s. If I look at homework scores for B, I don't have any 40s, 50s, or 60s. And so what I need to do there is just leave them blank. So then I go to the 70s, and I have a 73, a 74, a 75, a 6. So 73, 4, 5, 6. So you can see we back them this way. I also have a 78. Then I'll go to the 80s, and I have an 80, an 81, and an 82. So there's my 80, 81, 82, 84, and 87. So you can look at these two and compare them, and you can see that the red, or which would be homework scores B, are much more consistent than A. But what this allows me to do is I can actually see the data. I can see what we're going to call the distribution of the data. I can see that it's all clustered here, very consistent, versus the other one not consistent. So that's what we call a stem and a leaf. A box plot, also known as a 5-number summary, it must be 5 numbers that we're going to plot, has a picture that looks right here. One thing you don't see is the data. That's not a very good idea if I want to know exactly what the numbers are, but what it does allow me to do is it allows me to compare. We use these box plots or 5-number for comparison. How does it help me with comparison? Well, let's go ahead and find the 5 numbers first, and then we'll look at what it means for comparison. So the 5 numbers, the first one we're going to find is the minimum. That would be that little mark that's on the left, the smallest number. The next one we call Q1, which is a quartile or a quarter. And then the next value is the median. Notice we don't call it quartile 2. The fourth one that we're going to find is quartile 3, or the third quarter. Why wouldn't we call the median quartile 2? Well, because quartile 2 would be the 50%, which would be the median. And the last number we find is the max. So the min and the max are these guys out here. And the median is this line right there. And lastly, quartile 1 and quartile 3, you can see are beginning and the end of the box. And so if you look at the top box plot, you can see that it is very consistent. They're bunched together, where the one below it is not consistent. And so how we create these is just simply on a number line. So we have some data down here below, and we're going to just kind of sketch this thing. So I have a number line, and it looks to me like the median of this is data set for one of them is going to be 60. So if we take and look at the data set, and to this data set on the top, there's going to be two of them, and these were the box plots above came from. If I take a look and I start heading in both directions to find the median, I'll find that median to be 60. And notice there's 1, 2, 3, 4, 5, 6 on each side. So on my number line, 60 would be my bar. Then with these remaining numbers on this side, I'm going to find the middle of those. That would be quartile 1. It looks like it's about 57 and a half. So it would be in this area. That would be quartile 1. And on this side, keeping my number line space the same, I would find the edge of the box here to be 62 and a half. So there's 62 and a half is about right in here. So I just formed the box. It doesn't look like it's so evenly spaced, but that's okay. And this should have been 57 and a half, so it would have ended right here and not have been this part of the box. And then what I need to do is find the min, which is 55, and the max, which is 65, someplace out in this region, and that's how I would construct. So it goes right off a number line. So those are two different ways that we're going to be constructing. They both do comparison. The box plot does not show the values in the data set. The stem and leaf does.